Hello, class. Here with a short office hours video where we're going to talk about question number 1 from the definite integrals assignment, which I've gotten a few questions about. So here is mine. I've gone ahead and marked off all the points where we can read off the coordinates in the graph. So these are all the points in the graph that I could see in my graph. Your graph might be different, might be the same. But once you understand how we're going to do this question, you'll be able to go back and do your own whatever it happens to be. So from comments and questions I've gotten by email and by the forum, I gather there's two central sticking points in this question. One is that there's the semicircle down here, and the other is that this point there is not at an integer. Okay, so I want to address each of those in turn. Okay, so first of all, let's find the area of this circle. So because this circle goes from 2 to 4, that means its radius is 1. So that means the area of the circle, remember the area of a circle in general is pi r squared. However, this is not a circle, it's half a circle, so its area is pi times 1 squared over 2, so the area of the blue region is pi over 2. Okay. Note, this is not part of what's going to get counted at the end of the day by our integral, but it's important to figure out, and we'll see how it exactly factors in later. Let me go ahead and now resolve this question about what this point here is. A lot of people have asked if you could guess at this point, and you probably can't guess, but what you can do is note that this is a line that connects this point down here to this point up here, so I can find the equation of this line. So the slope of that line, it goes through 6, 4, and 4 minus 2, so the slope is going to be 4 minus 2 divided by 6 minus 4, which is to say the slope is 3. So this line's equation looks like y equals 3x plus b, and it passes through the point 6, 4, say. So that means that if we write this down, we get 4 equals 3 times 6 plus b. So b is minus 14. Okay, so this line here, its equation is y equals 3x minus 14. Okay, again, please note your graph might be slightly different, so your line might have a different equation, but you can still find the equation of the line by looking at the 2 points that are on it. Which means that I can also find the coordinates of this intercept here by setting this equation equal to 0. So namely, take 3x minus 14, set it equal to 0, and that'll give us 3x is 14, which will give us that x here is 14 over 3. So that means this point here that we could not read off the graph, it's actually the point 14 over 3, comma 0. Okay. Now, I'm going to do the rest of this, but I suspect this may be enough to get a lot of you going, so if you want to drop off here and go try and finish the rest of this question for yourself, and then come back to the rest of the video if you get stuck, I think that's probably going to be okay for a lot of you. Okay, but let's finish this off. So I want to break this down into the two areas that I'm going to have to deal with. I'm going to have to deal with this area over here that I have marked in orange. And I'm going to have to deal with this area that I've marked in yellow. Okay, so let's figure out what each of those areas is. Okay, so let's start with the yellow. Okay, and I should note before we go on, the integral, the answer I'm looking for, it's going to be the orange area minus the yellow area. So I just need to find these two and then combine them in the right way. Okay, so the yellow area, it's going to be this triangle, this kind of wedge-looking thing, and then this triangle. So the area of this triangle, its base is 2, its height is 2, so it's 1/2 of 2 times 2 plus, and then the way I'm going to handle this arch shape is that it's this 2 by 2 square minus the semicircle. So the square would include all of this space. Pretend that that was flat. And so it's that area, which is 2 times 2 minus the semicircle area. So that would be 2 times 2 minus pi over 2. And then plus the area of this triangle, which is 1/2 times, and then the base is the distance from 14/3 to 4. Times, and then the height is again 2. Okay, so that's a big giant mess, but if we go ahead and simplify it, it's not so bad, because that's going to end up being equal to, so that's just 2 plus 4 minus pi over 2, and this is plus 2/3. So you have 2 plus 4, that's 6 in thirds, that would be 18/3. So together with that 2/3, that'll be 20 over 3 minus pi over 2. That's my yellow area. I then also have to find the orange area. So when I go to do that, let's do that here. The orange area is going to be split into a triangle and a rectangle. So the triangle here goes from 14/3 over to 6. So its area is 6 minus 14/3 times then the height, which is 2, and then times the 1/2 that goes at the front that I did not say, and then wrote it in markers so I couldn't erase it. But 1/2 times the base times the height, just written in an unconventional order, we'll say. And then plus the area of this rectangle, which goes from 6 to 7, so it's 1 wide, and then it's 4 high, so 1 times 4. Okay, and so I can do a little bit of work here. That's 4/3 plus 4. 4 in thirds is 12, so this is 16 over 3. That is the orange area. So we said this integral was the orange area minus the yellow area. So here we have the orange area minus the yellow area, and when you make sure you carefully distribute your minus sign here, you end up with this number. All right, we'll wrap up there for this video, but let me know if you had any questions or anything I went over in this that you got confused by or sidetracked by or anything like that. Definitely let me know. But for now, until next time, be well.